In this video, we will talk about the mole ratio and how to conclude the suitable mole ratio to solve the problem if we want to calculate the moles using the moles of another substance. The mole ratios we can conclude from the balanced chemical equation. So we have to have a balanced chemical equation to get the suitable mole ratios. For this chemical reaction, nitrogen reacts with hydrogen to form ammonia. We can conclude the mole ratios from this many mole ratios from this reaction. If we want to conclude the mole ratios, we have to focus on just two substances from the whole substances in the reaction. We may have 3, 4. Sometimes we have just two substances in the reaction. We want to focus on just two substances. Let's say that we will talk about or focus on nitrogen and ammonia. So the suitable mole ratios between nitrogen and ammonia is that if we have 1 mole of nitrogen, it may produce 2 moles of ammonia. Or on the other hand, that if we have 2 moles of ammonia, it's supposed to be produced using 1 mole of nitrogen. I like to read the mole ratio or the conversion factors because we will use mole ratios as conversion factors. So I like to read the conversion factor from the numerator to the denominator. From the denominator to the numerator. From the denominator to the numerator, like this one, if we have 1 mole of nitrogen, it will form 2 moles of ammonia. Or if we wanted to produce 2 moles of ammonia, we have to use 1 mole of nitrogen. So I like to read the conversion factor or the mole ratio from denominator to the numerator. So the questions in this case may come in a way like if we have, for example, if we have 6 moles of hydrogen, calculate how many moles of ammonia formed. Calculate how many moles of ammonia NH3 formed. So in this case, it is different from the first case we solved before. So the substances we will focus this time on are hydrogen and ammonia. So this time we will focus on just those two substances and we will ignore nitrogen. The suitable mole ratios between hydrogen and ammonia are 3 moles of hydrogen will produce 2 moles of ammonia. Or if we want to produce or form 2 moles of ammonia, we have to use 3 moles of hydrogen. 3 moles of hydrogen. So those are the suitable mole ratios we can conclude from the balanced chemical equation. But in this case, which one of them we will use in solving this example? As I said before, we have to read the conversion factor from the denominator to the numerator. The denominator is the known and the numerator will be the unknown. So the suitable conversion factor in this case will be, if we have 6 moles of hydrogen, so the denominator will be the known. If we have 3 moles of, in the beginning, if we want to solve the problem, the first step is writing the suitable conversion factor. In this case, we will ignore the equation itself. We now know that the relationship would be between hydrogen and ammonia. Done. So ignore the equation and don't look at the numbers in the equation like right now. Just try to conclude the conversion factor without looking into the question. If you want to conclude the conversion factor, look at the balanced chemical equation. So in the balanced chemical equation, the suitable conversion factor, if we know hydrogen and we don't know nitrogen, so hydrogen will be in the denominator and the nitrogen will be in the numerator, and we have 3 moles of hydrogen to produce 2 moles of ammonia. Now we can multiply the number we have in the equation. It is 6 moles of hydrogen. So we can just try to make sure that we use the suitable conversion factor. We can make sure that we use the suitable conversion factor, that we have moles of hydrogen right here and the moles of hydrogen in the denominator. So now if we multiply 6 multiplied by 2 divided by 3, it will be 4 moles of ammonia. Now, as a revision, the mole ratios, we can conclude the mole ratios from the balanced chemical equation. We can conclude many mole ratios in the balanced chemical equations that according to the number of substances in the chemical equation. It may be 2 substances, 3, 4, 5 substances in one chemical equation. According to the number of substances in the chemical equation, we can know the mole ratios. In the questions, they gave us number of moles of a substance and they ask about number of moles of another substance. So in this case, for this example, we have 3 substances. In first case, that red one, we want to write more ratios between nitrogen and ammonia. So we ignore hydrogen and writing the more ratios. If we look at the equations, the equation, we have 1 mole of nitrogen and 2 moles of ammonia. So if we use 1 mole of nitrogen, we will produce 2 moles of ammonia. If we want to produce 2 moles of ammonia, we have to use 1 mole of nitrogen. And we give an example to being solved. It is how many moles of ammonia produced if we use 6 moles of hydrogen. So in this case, the relationship would be between hydrogen and the ammonia. So we will ignore nitrogen and we will try to write the suitable conversion factor from hydrogen, the relationship between hydrogen and nitrogen. So the relationship between nitrogen and hydrogen will give us 2 more ratios, that if we use 3 moles of hydrogen, we will produce 2 moles of ammonia. And if we want to produce 2 moles of ammonia, we have to use 3 moles of hydrogen. If we want to answer the question, just ignore the question itself and try to conclude the conversion factor from the balanced chemical equation. The relationship is between hydrogen and the nitrogen. We have hydrogen and we ask about nitrogen. So hydrogen that we have would be in the denominator and ammonia we want would be in the numerator. Then we write the suitable conversion factor, multiply by the number we have in the question. So just complete the calculations and get the answer for this question. Thank you very much.